Okay, I'm now delighted to welcome Fatima Ebrahami, who is a principal research physicist at the Princeton Plasma Physics Lab. Fatima.
Okay. Hello, and thank you. And my name is Fatima Ebrahami. I am physicist working on fusion energy and also astrophysicist. But somehow I became the inventor of the magnetic reconnection plasma thruster. And so I'll take you for the last talk to space. And I don't need to explain that for next generation propulsion technology, we really need next generation of propulsion technology to shorten the trip time to space, to any kind of travel, space travel. And existing solutions, the chemical solutions, are either fuel inefficient or produce really small power or thrust, the electric propulsion. So here there is a gap with no available solution. And to fill in this gap, you really need high thrust and also high exhaust velocity to be able to fill in this gap. And our solution here cover the current gap for deep space travel, and it can power by solar panel, also by nuclear electric. And it's efficient because it accelerates plasma, these conducting gas ions, to high velocity, and also it produces large thrust and also continuous thrust and adjustable thrust. And our solution, shown to the right, is a brand new way to generate thrust electromagnetically. And it's inspired by solar flares and experiments in the laboratory. That in this experiment and in solar flares, there's a process we call magnetic reconnection, where magnetic energy is converted to kinetic energy. And in the laboratory, we actually produce this kind of plasma ring that generates at high velocity. And that's how the scheme started with. And unlike fusion experiment that we want to confine plasma, we actually here, we want to get rid of the plasma, and we want that the plasma escape in one direction. So, and that is the source of it. And here the column in purple shows the key advantage of this technology compared to other schemes. In particular, the fuel flexibility, that it can run with wide range of sources, local sources in space, and therefore it's the refueling is really cheap. And also the simple design of these thruster is also really favorable. And the fact that it doesn't have moving parts. So that's also the engineering, it's kind of favorable. And for applications, we are considering for short-term application delivery supplies from low Earth orbit and closer orbit to moon. And that's the short-term application. And for that application, internally in our lab, we are working to we have been designing and also developing a thruster, at small scale and also small power for this application. However, about 2 million is needed to actually complete this prototype and also do customer engagement and also testing it for different applications. And this is the short term. Of course, the long-term application will be also using it for heating the plasma for fusion energy application. And that's the upside of this technology. And thank you for your attention. Thanks. Yeah.
Check out the full playlist from the 2022 Innovation Forum or visit kellercenter.princeton.edu/innovation forum to learn more. Subscribe for more videos on entrepreneurship, design and design thinking, societal impact, and innovation coming out of Princeton University.